All right, so welcome back. Today we're going to move on to the next thing that we're going to talk about, which is encapsulation. Encapsulation is actually a general concept. The way that it's realized in C is through what are called structures. Remember that we are live on Q&A session is live on Piazza and of course on YouTube right now. So the problem here is something that was illustrated in your lab yesterday. Built-in primitive types. And when we say primitive, we mean, say, integers or doubles or chars, or even in C, any pointer types are still primitive types, are limiting, right? Not everything is a simple number or character, or even just a string, right? Real-world pieces of data, real-world entities, are made up of multiple pieces of data, right? And the example that you saw yesterday in your labs was a baseball team, right? And that was a very simple example where you had a name, the number of wins, and the number of losses. You took those two pieces of data and you collapsed them into just one less useful piece of data, which was the win percentage. And if you take a look at the code that we actually put in there, you were actually maintaining two different arrays at the same time. So if you took a look at the code that sorts that stuff, it actually had to keep track of that if this team's win percentage is higher than this win's team percentage, not only do you have to put the win percentage up here, but you have to put the name up here. They were two distinct pieces of data. And that is not a great solution, right? Example, Lab 10 had baseball teams. All right. It is a bad idea to represent real-world entities with separate pieces of data, right? Lots of bookkeeping. In other words, if you're going to if you have the wins and the losses and the name all in three separate arrays, then you're going to have to keep maintain an ordering of all the three of those things. And if you swap two things, then you have to make sure that the other two arrays are swapped in exactly the same way, right? Ideally, those pieces of related data should be collected into one unit or thing, or in this case, entity, right? In C, that entity is a structure, right? And structures allow you to achieve what's called encapsulation. This is generally referred to as encapsulation, right? Now, if you pull out the dictionary definition of encapsulation, encapsulation simply means that you're taking stuff and you're encapsulating it into, a box, right? You're moving or something. So you take all your dishes and all your silverware or something, you throw them into a box, you encapsulate everything in there, right? In programming terms, it means three things. First of all, it includes the grouping of data. And that's actually what we're going to want, because that solves the problem. As long as we can take wins, losses, and the team name, and we can group them all together into this one unit, we no longer have that problem of treating them all as separate pieces of data. The grouping of data, the protection of data, and three, the grouping of functionality that acts on that data, right? Unfortunately, this is more of an object-oriented programming concept, more of an OOP equals object-oriented programming concept, right? C is not an object-oriented programming concept, so C only really supports number one, right? The grouping of that data. There are conventions whereby you can protect that data from the outside world, but there's no strong protection like you have in, say, Java or C# or C++ or something like that, where you can encapsulate variables and make them what's called private. And then nobody in the outside world, outside of your class, can see it, right? The grouping of functionality that acts on that data simply means taking any methods that say, act on baseball teams and putting them inside as well as the name, the win percentage, and or the wins and the losses, and then you take all these other functions and you throw them in, right? Computing the win percentage of simply just taking wins divided by wins plus losses. That kind of functionality would belong to the structure as well. Unfortunately, there's not an easy way of doing that in C. So C really only supports number one, the grouping of data. To illustrate this, we're going to take a look just at I'm going to do this tutorial style. We're going to create a structure to support, say, a book and an author, right? So defining structures, right? Here's my goal. Define a structure that models a book, right? So I'm going to come over here, and here's my first attempt. First of all, here's the syntax. Pretty easy. Type def struct. Where have we seen type def before? Enumerated types. Type def enum means that you are defining an enumerated type. Now type def struct means that you are defining a structure. Right? Also, opening and closing curly brackets. At the end, you give it the name of the structure. So if I want to model a book, what should I call it? Book, right? There's really no reason to get fancy, right? They call things what they are, label things what they are on the tin, right? It's a book, okay? We'll talk about naming conventions and style here in a moment, but I want to do this just on the fly. Right? So, define a book. What is a book? What are the aspects of a book that you would want to know? What's a book that you're reading right now? If you want to, anybody want to volunteer? The Iliad. Okay, the Iliad. What would you say that the Iliad is? A series of chapters. Okay, a series of chapters. I mean, like page number of pages. Okay, number of pages. But the Iliad itself, the Iliad is its title, right? What else? Author. Okay. Number of chapters. Okay. Number of chapters. We could actually store the entire text if we really wanted to. I don't want to go that far. In fact, I want to keep it simple, and let's just have just a few of these things. I do want to have a release date or publish date. Right? Getting ahead of myself there. That's good enough for a start. Now, let's go ahead and start talking about syntax. The title, what is that? Is that an integer? Is it a double? Is it a single character? What do you think it is? A string, so it'd be more appropriate to call that a char star, right? Title, okay. Note here, we'll codify this later on, but what did I do with the name of my structure? I used upper camel casing. For the member variables of my structure, I'm going to use lower camel casing, okay? What about an author? Char star author, okay. That's my first attempt here. To do. Really? I don't know. Let's come back to that. Reconsider. Question mark. Number of pages. What's that going to be? An integer, because of course you can't. I guess you could, if you tore some of it out, you could have a half a page or something like that, but you don't want to do that. Publish date. What is that? So I don't know if we have a publish date on Iliad. An exact date, just a 3rd century BCE or something like that. I don't know. Yeah, exactly. A couple of centuries there. Right? Is there a more modern book that we can? I don't know. I am reading right now. It was just released very recently. Christopher Moore, Shakespeare for Squirrels. I don't know if I spelled that correctly or not, but it doesn't matter. There. Okay, so that's his website. Hopefully that's going to be appropriate. There we go. I found that was September 13th, 2016. Okay, so I've got mine right now. So May 12th, 2020. That's the date, right? So published date. How would I represent a date? How did they represent a date right here? If I just take all those characters and smash them together, a string, okay. What's another way of representing a date, though? I mean, we could do that. We could say char star publish date, and then what we have formatting issues. Format, maybe it's 2020 slash 10/21, or what was it? May 20th, 12th. Thank you. What's the problem with formatting like that? Is this European? Is this American? Is this, it's inconsistent? In other words, is this the month or is this the month? Is this December 5th or is it May 12th, right? Well, okay, fine. What if I did a format like on Amazon there and went May 5th, 2020? Okay. In fact, there are much better dates, right? There's an ISO 3306 date format, I think it is. ISO date format. I forget what it is. 8601, there it is. So, there is the perfect way of representing a date, right? A very standard way of, it's lexicographic. It always puts the year, then the month, then the day, so that if you sorted a bunch of dates, they would be in chronological order. It makes sure that you have leading zeros. So if you have May, it would be 05. It wouldn't just be 5. It doesn't use ordinals like the third or RD or TH or anything like that. It then has a T and then an actual 24-hour time, unless you want to. You can be more specific with a Greenwich Mean offset. Awesome. That is the perfect way of representing a date using a proper standard like this. I want to keep it simple though. We can represent it like a string, like an ISO 8601. Another way of doing this, by the way, is Unix time. Unix time represents the number of seconds or microseconds or something like that. What is it? Seconds since the epoch, the Unix epoch, which is January 1st, 1970. So to go back in time before 1970, it would be the number of negative seconds beforehand, right? In other words, it represents it with just one number. If it were an integer, then you have a problem in a couple of years here. Where is it? Unix epoch time problem. I think it, yep, there, 2038 problem, where we are going to run out of numbers if you're using a 32-bit signed integer, right? At that point, then the Unix epoch will hit, and just like Y2K and all computers that were using 2 digits to represent the year goes back to 1900, we will go back to 68 years prior to 1970, right? Well, okay, fine. We'll use a 64-bit integer to represent time, and now we're good for several, billion or trillion years or something like that, right? Everything has drawbacks. Everything has an advantage. Everything has drawbacks. With an integer, it's really simple. It's just a number, right? And it is completely orderable. Well, then you have problems like the year 2030 bug or the Y2K bug, right? If you've got strings, well, that's more exact. This is not it, but the ISO 8601 format, that's more exact, but then you're dealing with strings all the time, right? Which is somewhat less efficient. Not only that, but you have to make sure that you are adhering to the format, and meaning that you're going to probably want to bring in a library to do it for you. There's another way that we can do this. I want to keep it simple. And let's say that a publish date is a year, month, and a day. Right? So each one of these things is going to be, say, an integer, and an integer. Right? So let's go ahead and say int publish date year, int publish date, I don't like typing, month, ... right? Except wait a second, what am I doing? Encapsulation means that you're taking pieces of related data and encapsulating them into one object, into one thing, into one entity. This looks like 3 pieces of data to me that are all related. So what should I do? Let's put it into another structure. Right? Type def struct. You're not limited to one structure, you know. we can create a date structure that has those things in it. Let's say year. Now you don't have to put publish date year in front of everything, but it'll be say int year, int month, and int day. Right? So 3 integers. That's another way that I can represent that. Right? Now I can just move. This is my own user-defined type. I can go ahead and make this into a date. Right? Excellent. The problem is now, when I go ahead and compile this, or gcc demo.c, it's going to have a problem with it. It doesn't know what date is. Unknown type date. Why? I use it here. I declare it down here. So, order matters. Right? If you're going to use it, you need to declare it first. There we go. Now that's got me rethinking. Let me get rid of this stuff here. Now that's got me rethinking this author right here. What is an author? A person. Last name, first name, date of birth, ... all these things. What is that screaming out as a red flag that I should be doing? Probably making another structure. Right? The whole reason that we make structures is so that we can model real-world entities. And if we're conflating a book and an author as the same entity, then we're not really modeling the real world, right? So let me go ahead and make one more. Type def struct. And for this one, you can call it author if you want, but maybe it has a use beyond just authorship. Maybe it has there's an editor. Maybe there's a reader. Maybe there's a user that's eventually going to rate these books on a scale of 1 to 10. You're on Goodreads.com or something like that, and that user can be a person as well. So I'm going to keep this general as a user. Char, first name, char star last name. Of course, we could have a date of birth as well, which would be a date of birth, right? So we could reuse our entities over and over and over again. And instead of having just a simple string, I would have a person, which is an author. Because if I only had one string to represent a person, is it going to be first name space last name? Is it going to be last name, comma, space first name? Is it going to be first name, middle initial, last name, middle initial with no period? There are way too many issues with that are solved by simply separating those pieces of data out. Now, of course, you can go overboard and engineer everything in the social security number, NUID, et cetera, et cetera. We're not going to need that yet, which is another good, I think I've mentioned it before, but it's another good acronym, YAGNI, right? You ain't gonna need it, right? So don't over-engineer things, right? Make it reasonable, right? If later on you have a need for modeling a social security number for some reason, then go ahead and add that to your model, right? You ain't gonna need it yet, though, right? That looks pretty good, right? We've got a date, we've got a person, we've got a book. Let's make sure that it actually works, right? Great. Now, let's talk. This is my first design. Of course, I'm not doing anything with it yet, right? But this is my first design. Let's go ahead and put this in the notes, and then let's talk about what we did. All right. Let's see. There we go. All right, so some observations here. All right. A structure is composed of multiple pieces of data. All right. When a structure can be composed of primitive types and or other structures. Right? When a structure owns another structure, it is called composition. Right? That in this instance, we have a person structure that owns an instance of the date structure. We have a book that owns a date and a person. Right? It's composed of other things. It also owns primitive types like char star or an integer here for the number of pages, etc. right? We also might want some identifying information, right? If I put in, say, a char star, how do we identify books, by the way? ISBNs, right? Excellent. Right? So we could also add that to our how do we identify people? Although there could be many John Smiths out there. Social security number, that's one way in the United States. Tax ID numbers. If you're in a particular institution like UNL, everybody is uniquely identified by an NUID, right? Those are called keys. Unique keys or primary keys in a database, which we'll eventually get to in computer science too. But those are called external keys. We could also internally in our own system, we could generate unique keys for every single person if we were actually persisting this, saving it to a database or something, or loading it up from a database. We're not going to go that far. Again, you ain't going to need it yet, all right? So I'll go ahead and just go with ISBN there. When a structure owns another structure, it's called composition. You may want to design a unique identifier field, right? And sorry, I didn't introduce the term field. Each variable in a structure is a member variable or field, right? So ISBN is a field, title is a field, right? Or member variable, okay? Styling and convention and conventions. Styling conventions, right? This is just one way, by the way. This is more of a modern naming convention that I'm adopting. There are plenty of alternatives out there, but the one that I demonstrated here is that names of structures use upper camel casing. Right? Names of member variables or fields use lower camel casing. There we go. You provide or styling conventions and syntax, right? You use type def, right? Struct, and opening, closing curly brackets to define what the structure is composed of. Another difference here is when we did type def enum, we had an enumeration, so item A, comma, item B, comma, item C. We don't have that anymore, right? These are actual variables, not valuables. So what do we put at the end of our variable declarations? A semicolon, right? Semicolons end each variable, right? You provide the name of the structure at the end, followed by a semicolon. Right? Semicolon right after book here, or right after person. Right? Order matters. You must declare a structure before you can use it, or use it in other structures. And for that reason, usually structures are declared in a header file, right? And usually have the same name. So like book.h, and then all the prototypes that go along with book. Author.h if you want to separate those out. I'm not going to get that fancy because Yagni, you ain't going to need it yet, right? So once we've got our structure, how do we start using them? Using structures, okay? So I'm going to go ahead and create this Christopher, I don't know, has anybody read Christopher Moore? No? Okay. Comedy, basically. It's a satire of Shakespeare stuff, of Shakespeare's plays. So let me go ahead and create a book, right? B, right? Or I could call it what it is, Shakespeare for squirrels, but I don't know how to spell it, so I'm just going to keep it as B, right? Now I've got a book, right? I can set the elements of this book using what's called the dot operator. Why is it called the dot operator? because it is a dot. Number of pages equals, I think there are 270 pages in the book, right? 272 or something like that. So if I've got a variable called b, then b dot, and then the name of the variable that you want to access. In fact, for that reason, this is actually not technically the dot operator. It is called the direct component selection operator. But who wants to use that? What is it? It's a dot. So just call it the dot operator. Right? That's much easier. Can I do this? Title is equal to, I'm just going to cut and paste this since I don't know how to spell squirrels. And I won't have the colon. I'll just do this. All right? Shakespeare for, can I do that? That was one of the most common mistakes that we saw in labs yesterday, where people tried to use the assignment operator for strings. Can you use the assignment operator for strings? Well, you can, but it's not going to give you what you want. What do you need to use? str cpy. Copy into this string value over here. Excellent. Okay. What's the problem there? What is the title right now? It's just a char star. Did you see a call to malloc anywhere? No. So one thing that you can do is you can hard code stuff 500, right? You can just put in a static string that is now if there's any title that is more than 499 characters, then you're screwed, but 500 is reasonable. I don't want to do that though. There might be a very, very long title out there and I want to do this properly. I want to use dynamic memory. So let's go ahead and create a string using malloc so that we can actually copy into this thing, right? So b.title is equal to a call to malloc. How big do we need? Well, here's the title. How many strings is that? Or how many characters is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 25 times size of char. Is that going to be enough? No. 25 plus 1. Why? For the null terminating character. I hope I got it right too. We're going to look at a better way of doing this anyway in a second here. That takes care of the title. ISBN, I'm going to have to do that too, right? I'm going to have to copy pasta, ISBN, and I don't know what is the ISBN of find ISBN. All right, there are two ISBNs there. So there's ISBN 13. So it's 13 because I assume that it has 13 characters plus this, so it's going to be 14, right? Something like that. Okay. What about person? Well, now I can do the same thing for the first name and the last name of the author, but I've got composition here. The book.author, that is another structure. That structure is also composed of other things. How do I set this up for the last name and the first name? I then use the dot operator again. Last name is equal to a call to malloc. How big? Last name would be more, so M-O-O-R-E. So in 6. 5 plus 1, 6. That's the last name. And then strcpy of b dot author dot last name dot of more. And then it's kind of sad that I never remember how many. He has the same name as me, but I never remember how many. Christopher, 5, 6, 7, 8, 9, 10, 11, 12. All right, whatever. I'll just overestimate there, right? 30. 30 is good enough, right? So you see me typing a lot of stuff, right? Let's do Iliad now. What do I have to do? Cut and paste this huge thing to create a book for Iliad, right? Change all that stuff. Give me another book. The other book okay, yeah, go ahead. 1984, right? George Orwell, etc., right? Published in 1940, 9, I believe, because it was 48, but serialized, and then originally, then it had to wait till 49 to be published or something like that. So it didn't completely work out. He got 84 because he just, switched around 48 when he wrote it. But anyway, cut, paste, cut, paste. Does this sound like a good strategy? A function. Let's write a function to do something like this. Let's write a function to create a book, right? So maybe it returns a book. I don't know. What does it return? We'll figure that out here in a second. What should it be called? CreateBook? All right. CreateBook. What should it take? Everything that a book is. An ISBN, a title, an author first name, an author last name. And just to keep it simple, I'm going to forget about publish date for now. All right. But we could take, and I'm going to also forget about number of pages. Well, actually, no, I do it down here, so I might as well do it. Right? Cut, paste. Let's move this up here instead. So, char star title. Char star, what else do we want? ISBN. Let's go in the same order here. Title, char star, author, first name, char star, author, last name, and yeah, let's go ahead with int num pages, right? Number of pages or whatever. Okay. In fact, yeah, I like to be consistent and use the same exact variables so that there's no chance of you screwing it up. Right? But am I going to be making changes to this ISBN? Nope. So const char star everywhere. Const char star everywhere. Const char, const char, const char. That is a really long line. Here is an acceptable trick. You can go down to the next line. And now they're all in a nice organized column instead. If you want to go ahead and align it, that's your business, as long as it is consistently aligned. Okay? We'll come back to the return type here in a second. Book B. Actually, no, let's talk about it now. I could return a book. All right? But you have to be careful here. This will work, but what's happening is there's a book, and it's a string pointer, a character pointer, another character pointer, a person, which is another structure, which is 2 other character pointers, which is also a date of birth, so 3 more integers over here. We've got number of pages, which is another integer, and we've got another date here, which is 3 more integers. That could, I mean, that's at least 50, 60 bytes. Right? When you return a book, what happens under the hood is what's called a mem copy. That whatever book I create here locally, it'll end up copying that onto the program stack, and then the returning function gets ends up copying that into its variable. So if I call this function like book B is equal to CreateBook, and I'm going to grab all this stuff now. There's the ISBN, Shakespeare for Squirrels, and Christopher Moore, and 270 pages or whatever it is, right? When I call that, it'll work. It'll work by copying all those bytes onto the system stack. That's fine for small structures, right? But it's still all static. It's all manipulating your stack, right? And you do risk a stack overflow, especially if you are going to be passing stuff, passing an entire library of books. 500 books or something like that, then you're passing an entire, it's a little bit different there, but basically, this is not the best strategy, right? Necessarily. Now, there's plenty of use cases out there where you would return a static version of this and then let memcopy take care of it for you. Your code with this assignment operator is actually being replaced under the hood with a call to this function called memcpy, which is memory copy. It copies this chunk over here automatically for you. Right? I want to do it differently, though. I want to dynamically create a book using malloc and then return that dynamically allocated instance of a book. Right? What does my code look like now? Well, I can't create a local variable like this because you can't return once you return, it's on the stack, it'll end up getting popped off the stack and it's gone. Right? Instead, I want to do a call to malloc. It's going to be a book star because that's what I've got over here. Malloc, how big how many bytes does it take? Well, because malloc, you ask for a certain number of bytes. Does it take 40 bytes? Does it take 50 bytes? Okay, well, a char star, I'm guessing that's 8 bytes because it's a pointer. I'm guessing that this is 8 bytes, so 16. This is an author, which is another 2 of those, so it's 32 bytes now. There are 3 more integers over here, so that's another 12 bytes. What am I up to? 44. And going back down here, there's another one, so 48. There's another one with 3 integers, so that's another 12. 60. Right. Should I have to do that math in my head every single time? No. What tool do we use to determine how many bytes something takes? Size of. If it were an integer, fine. If it were a double, fine. But we can also now use book because we defined it up here. Compilers are dumb, but at least they can go through and find out, oh, okay, I can count up the number of bytes this requires. I'm good. Right. Compilers can count at least. Okay? Excellent. Now that I've got that, I can set this equal to the number of pages rather than hard coding it 272. The problem is I can no longer use the dot operator here. In fact, let me show you what happens when I try to compile this. All right. Invalid initializer, blah, blah, blah. There we go. B is a pointer. Did you mean to use this thing instead of the dot operator? So if you have a pointer to a structure, you have to use different syntax. What does that thing look like? An arrow. So let's call it the arrow operator. Right. We'll use the arrow operator instead. The technical name is indirect component selection operator. Who cares? It looks like an arrow. Let's call it an arrow. Yeah.
I was just going to say, and you commented it out already, but in the b.isbn, in the string copy line, it has b.title.
Okay. Help me fix it. So that's a consequence of, sometimes they do that on purpose to show consequences of copy pasta. So let's correct all this stuff together now. I still need to set up memory for ISBN, but no longer is it hard-coded to 14. I mean, all ISBNs will be 14 characters long, but I don't want to depend on that. Let's go ahead and use strlen of ISBN, time size of char. Then use strcpy, correcting that, thank you, using the arrow operator, but not hard-coding it, using the given ISBN. Let's do the same thing for the rest of them. We will change this to arrow operator, arrow operator, arrow operator. Title, strlen of title, +1. Why always +1, +1, +1? Because of the null terminating character. But I see myself doing these 2 lines over and over and over again. Is there a big red flag there? Let's write another function. Say even one that I'm just going to steal one from class. Deep string copy, if you remember we did that one in class. I'll let you do that as an exercise though. Right? I will go ahead, well, I don't know. Is it worth it? So there's this great XKCD comic. If you're not familiar with that, it's a comic for nerds. XKCD. When is automating worth it? Right? So when is it worth it? Is it worth your time to do something? How often do you do it? How often do you do it? How much time does it take you to do? And so if you're doing something very frequently, even if it takes a small amount, then it is worth it to automate it. If you are doing something very infrequently, and it takes you very little time, then okay, it's kind of annoying, but it may not be worth your time to actually automate it, right? So it's a good way of thinking about things. If you spend every day doing doing something that takes you 5 minutes, whereas you could invest, say, an hour into automating that thing, right? Then your savings, you realize your savings in only 12 days or something, right? After which point, now you get 5 extra minutes for the rest of your life, or as long as you're doing this thing, right? So it's a good way of thinking about things. Is something worth automating or not? Is writing a deep string copy function here worth it or not? Well, by now we've thought of, we've spent more time deciding whether or not it's worth it than just doing it, but that's another consequence, right? Then you get into what's called bike shedding. All right, so char star deep copy. It's definitely worth the time to go back into my notes and just cut and paste it because I've already written it. But const deep string copy, let's call it const char star s, and now I will grab these things down here. Not B, but char result, or say C for copy, string length of S, copy into C, S, and then return C. Excellent. Now I can go ahead and get rid of all this garbage, right? Deep string copy of ISBN, deep string copy of title. Now I don't even have to worry about that +1 every single time because it's taking care of it for me. There's title, last name equals deep string copy of last name, and finally first name, first name. Ooh, clean code, right? Clean code is always better than dirty code, right? Return B. And now this should copy, or clear. Actually, no, it won't. It should not compile yet. There's still a problem here. This is an invalid initializer, right? CreateBook returns a book star, a pointer. I need a pointer here. Right. Come on. Right. Great. Now it should compile. Right. What's wrong? Oops. First name. Did you mean last name? Did I? Author. Oh, sorry. Last name. Author last name and author first name. There we go. And then if you wanted to, you could go ahead and move these around because that first then last. Just be consistent about these up here. And if you want to be consistent about that, let's pull that down there. There, I like that better. All right, more organized. Now let's go ahead and compile. All right, runs, of course, it doesn't do anything because I just create something and then I immediately die. The program dies, I should say. But now we at least have a start. I can create book after book after book. So B1, B2. What's the other book that you're reading, they said? Say what? Okay, 1984. 84, George Orwell. All right. The $7 version. All right. What is the ISBN here? Grab that. There's that ISBN. 1984. George Orwell. I don't think it's very long. Pages, 328 pages. 328. There we go. Yay. Now because I put this into, this is referred to sometimes as a factory function, or why is it called a factory function? Because it manufactures book instances, right? Sometimes in object-oriented programming languages, they're called constructors. Why? Because it constructs a new instance of an object, right? Since this is not an object-oriented programming language, sometimes people call these factory functions so that you don't have to have this big chunk every single time you want to create something. Instead, you call that function and then create one after the other. Right? All right, what else would be helpful here? Oh, okay, you could have to-do, create a. Now in object-oriented programming, we call them constructors because they construct something. What do you think the opposite of that is? A deconstructor, or we call them destructor. All right? Structure. Whore. There we go. Create a destructor, right? So void free book, right? Book star B. Right? And it can't be const. Why? You're going to destroy it. You're definitely going to write to it because you're going to free up its memory. So, yeah. Let's actually do it. I won't do a to-do here. So can I go ahead and free book? If I did that, what about the first name, the last name, the title, the ISBN? That is all now leaked, right? Those are all strings sitting out in the ether that I no longer have access to and that are taking up memory, right? And because I freed the book first, then I no longer have access to it. So I need to make sure that I do each one of those things first. Free the ISBN, free the title, free the author's, oops, sorry, I should be doing what? The book's ISBN, the book's title, the book's author's first name, the book's author's last name. There we go. And then I can free the book. What about the number of pages? Do I need to free that? Nope. Why? It's just a regular old integer. It takes care of it for you when you free up the book. Do I need to take care of freeing up the publish date? If it were a pointer, yeah, but it's not a pointer. It'll take care of it for me. Do I need to free up the person's date of birth? No, because it's not a pointer. You only free up things that are pointers, that are dynamically allocated. Right? All right, I can immediately free them. Free book. Did I call it free book? Yeah, I called it free book. Free books. Yay. All right, free both of those. So I can create, I can destroy. Is that it? Not much use if you can't do anything else with them. I want to brag about all the books that I've read this year. So here's a list of all the books that I've read this year. What should I do? Print them. All right. So let's write another function. Print books, right? Or print book. Let's just take care of one at first. All right. If I'm given a book instance, first of all, am I going to be making changes to that book, changing its title, changing its author? Probably not if I'm just printing it out. So you can make structures consts as well. And now any changes to any of the member variables are prevented. You can't change the title. You can't change the author or anything like that, right? I'll initially make this a void function. How do you want to print it out? Maybe title, by the author's last name, comma, author's first name, and then maybe in the year, maybe within the parentheses here, the year that it was published, except we didn't take care of that stuff. I'll just keep it simple. There we go. So title, by, last name, first name. So B's dot title, is that correct? Do I use the dot operator here? Or do I use the arrow operator because it is a pointer? All right. Title, author, dot, last name. Oops, I think I've screwed up here. No. Author is, how did I define it? Yeah, it is not a pointer, so I do use the dot operator. I could redesign this, and if you wanted to, you can make this into a dynamically allocated structure as well. I don't want to do that because then I'd have to go back and fix everything. So I'm going to go ahead and keep it as it is right now. So it's going to be down here. It's going to be arrow operator because B is a pointer. But when I get to the author, I use the dot operator because it's just a regular old structure. Yeah, go ahead.
If that was dynamically allocated, would you use 2 arrows?
Yes. If it were author star, then I would use arrow arrow. Yep, exactly. And then finally, B author dot last name or first name. Great. Let's print both of my books. Print book B1, print book B2. Yay! Shakespeare for Squirrels by Moore Christopher, 1984 by Orwell George. If I were printing this in a table, I could even do other tricks, like say, align everything, right? And align this. I don't know. Oh, that's way too much. There we go. Negative, and then not 40. Let's go down to, kick it down to 30, and let's only kick this down to, I think, maybe 15. And align it left. There. Now the titles are all aligned, and by are going to all be aligned, right? By putting in these placeholders here for strings. The negative is for left alignment, right? And left alignment, and the positive would be for right alignment. And then you know, you can take this out. You could just have nice columns everywhere if you really wanted to do it that way. Right? All right, that's nice. What if I wanted to print books though? Void print books. Ooh, take an array of book structures. How do I do that? Right? Before I do that, let's reconsider this function right here. This prints a book. Is there a way that I could make this a little bit more general? What if you wanted to print a book to the standard output? We've got our solution right now. Where else might you want to print a book? A file, right? Or everything is a file, so that takes care of everything, right? I could take a file stream and a book, and then I could print it to that file stream for you, and I'll take care of that. Or I could create another function that took a book and created a human-readable representation string and gave you that string. And now it's up to you. Do you want to print that string to a file? Do you want to print it to the standard output? Do you want to print it to whatever, right? So we could generalize this and have a book to string function instead, right? In which case we are going to have a char star returned. Right? Help me out. I need a char star result, right? S is equal to a call to malloc. Okay, so if we're printing the title, the last name, and the first name, I need to do string length of 1, 2, 3, add those all together. Add 1, 2, 3, 4 for those columns. I need to 1, 2 for these, and then end line character, right? I don't want to do that. Let's make something that's big enough. A temporary buffer. Now, if I ever have a string representation that is more than 999 characters, I'm screwed. But for now, this is okay. Right? And then what I can do is I can do sprintf. Have you seen sprintf before? Well, you've seen printf. You've seen fprintf. And I think we have seen sprintf. But remind me, what does S here stand for? It prints it to a string. Right? I'm going to take this format, and I'm not going to include an endline character here. I'm going to let you decide whether or not you want to end the line. Everything else is still the same. And it prints it to this temporary buffer string right here. Now what I can do is I can make a call to malloc that is exactly the size that I want. Right? String length of temp plus 1 times size of char. And I can do strcpy into temp into s temp, except you know what? I already put the work into it. Do I have to write those two lines? No. What could I do? Return deep string copy of temp. I don't even have to put it into a temporary variable. Since this returns a char star, I can just immediately return it. I don't have to clean up this memory. In fact, if I did clean up this memory, it would be wrong. First of all, the only place that I could clean it up is right here. And so I destroy it before I return it? No. If I put it down here, you're returning. This is now dead code. Can't happen. But even if I did it up here, I would get a stack smasher error because I am trying to delete memory that's on the stack. Memory that's on the stack gets cleaned up magically for me when the stack frame gets popped off the top. Don't worry about it. Right? Nice. Now I don't have a print book anymore. I can have a char star s is equal to whatever this function was. Actually, no, let's rewrite that. I do want a print book. But now that I've got this more general function, I could have a void print book const book b star b, right? And I can call this book2string function char s is equal to book2string of b printf %s and the line s and then return. And now I've got the exact same behavior as before. There we go. Shakespeare for Squirrels by Moore, Christopher, right? 15 is still large. Let's go down to 10, right? Come on. There we go. Great. Take a real hard look at that and tell me if you see anything that's wrong. You create a string dynamically using malloc. You print that string out. What happens to that string when you return on line 63? It's now a memory leak. Once you are done with it, done being you've printed it out, free it up. Right? Now there are no memory leaks. Okay? Valgrind would have caught that, by the way. Oops. CCC. Do I have a Valgrind's installed here, right? Okay. Valgrind. A.out. 2 errors. Definitely lost 111 bytes. Not that big of a deal, but you definitely lost it. Why? Deep copy string here. Malloc. It was never cleaned up. Right? In both, you call main called print book, which called book2string, which called deep copy string, which used malloc. That malloc was never cleaned up. And that's what Valgrind is telling me right here. Right? But if I get rid of that and run Valgrind again, 0 errors, 0 context. I didn't see anything that needed to be deallocated. In fact, it's also telling me that my free book here is probably really good too because it couldn't detect anything being leaked out of that. Right? Awesome. We're writing some good, clean code right now today. My other question was, what if I have an array of books? Right? So I've got book 1, book 2, book 3, book 3. Right? Create another book here. 1, 2, 3, 4. I don't know what it would be. You said Iliad? All right. Help me out. Like 1,000 pages or something maybe. Homer. Homer what though? No. No. Let's find out. I'm interested to see what this is. What this does. Let's actually do something with it. I think that it'll just print null in parentheses here. I'm pretty sure. Oh, no. Darn it. All right. Homer something. There we go. Or you said Simpson, right? There we go. Yeah, there we go. Homer Simpson. Once I've got 3 of something, I probably want to store it where? In an array. How do I create an array of books? Right? Here's one way. Book, library, right? And there. That will hold 10 books, right? But it's static. That can be an array. But wait a second. Book star, that's just one book. Book star, my library is just one book. Book star is just a pointer. Book star can point to a memory location that holds one book, or it can point to a memory location that holds 4 books, or it can point to a memory location that holds 5 books, and then I've run out of fingers, so I won't go anymore. Right? All we need to do is call malloc book star properly. How did we do that up here with CreateBook? Size of book, and here I'll emphasize it. How many do you want? Just one. That's why I didn't write one, but I'm writing it now to drive home the point that when we dynamically created a book, we were actually allocating memory to hold 1 book. If I wanted 2 books, oops, then there you go. If you wanted 3 books, I only want 1 book in there. Get rid of Siri there. All right. So if I want space enough for 3 books, then what? Size of book times 3. Once I've got my library of 0 is equal to B1, 1 and 2 and 2 and 3. Right. Careful, this will not compile. Right. Incompatible types when assigning type book, aka structure anonymous, from type book star. Library sub 0, what is that? Library is a book star. So think back to integers. If I have an int star with 5 integers in it, and I go array sub 0, that's 1 integer, regular old integer. So if I go library sub 0, this is a regular old book. Right? On the left-hand side here, this is a book. What about on the right-hand side? What is this thing over here? That's a pointer, book star. They are incompatible. So how do I make them compatible? There are actually 2 ways. I can make the left-hand side compatible by rethinking this declaration up here. Watch the videos for more. I'm not going to cover it in class. Or I could do the right-hand side and make it compatible by dereferencing it, making this book star into a regular old book. Right? Regular old book, regular old book. Clear this. Let's see what Valgrind has to say about it now, though. Okay, so it works, right? No errors there. What does Valgrind say about this? Definitely lost a whole bunch of memory now. Why? When I dereference it, that means I'm taking the pointer. Here's the book, right? My fist is the book. Here's the book. I'm dereferencing it. I am making it into a regular book. When I assign this book to this book, it copies over all the memory. Meaning that this is the library sub 0 over here. The original B1 is still over here, and it's gone. I mean, it's still there. I'm free. I can actually, sorry. No, I free it down here, so there's no problem. Never mind. If I didn't free it down, I didn't free B3. That's probably why it's complaining. Right? But you do have to be careful here, because this dereferencing, if I did it like this instead, if I did it with a call like this, that is definitely wrong. Why? Because it returns a pointer to this book over here. Then I dereference it, copy it over to library sub 0 over here on my right hand, at which point I've now lost this book over here that it was originally returned. Right? And so that's definitely a memory leak right there. But if I kept a reference to it like I did up here, and then I cleaned it up down here, there's no problem there at all. Right? Of course, I still need to clean up the library. Right? Free library. There we go. I don't need to, actually no, I would need to free each book in the library too. So to do this properly, or proper, by freeing each book. Right? Books, strings. There we go. I'll leave that as a to-do though. Okay? But you can operate on arrays of structures. This is one way of doing it. If you want to see the other way of doing it, where you've got a, in fact, there are two other ways of doing this that I cover in the book, in my book, and in the videos, where you can create an array of pointers to books, and now those books are all over memory in non-contiguous locations. Or the third way is that you can have an array of pointers, and then it points to a contiguous allocation of a bunch of books. Again, if you want to look at that, if you want to do it, get that deeply into it, then watch the pre-prepared videos, because I don't want to get into it in the lecture. Okay? All right. When we come back on Monday, we'll reiterate this stuff, but then we'll also say, as a starting point here, to do, create a print books function. Right? In other words, if I gave you multiple books, I want you to print out that table that we were printing out before. The one that looks like, well, it's way up there now, but there. I want you to print out this entire table. Right? Meaning that I now have an array of structures. I'll give you the array of structures. You iterate through the array of structures and print out each one separately. So I don't have to do it with 3 function calls down here. Print, print, print. You take care of that. Okay? Any questions? What's the point of the book to string function when there's a print book? Sorry, I should have been paying more attention to the QA on Piazza. It's because this is more general, right? I can take any book instance and create a human readable string out of it. Now you can go ahead and print that to the standard output if you want, like we did over here, print book. Or you can take that string representation and dump it to a file. Or you can dump it to a socket so that you can transmit it to another computer across the internet or whatever. You can do anything that you want with it as long as it's a string. Printing it to the print book to the standard output, that's just, that's one piece of functionality. This gives you a way of converting a book to the string and then doing whatever you want with it. Right? Wow, nothing on YouTube either? Okay. Very quiet. The Discord has become really quiet too, unless people are just hiding from me or something. Right. No questions? All right then. I will see you on Monday.